Hey team, sorry I've been out of the picture for YouTube for a little bit. We have been talking about probability for the entire past week, so I'm going to look at all of the things that we've been discussing with probability in the context of a spinner problem. So think of a spinner like Wheel of Fortune type spinner, etc. And I have two different ones. I have spinner A and I have spinner B. They have some of the same outcomes. You could land on red, you could land on green, you could land on black, which means that they have the same sample space. But the probability of landing on those different areas is actually pretty different, as you probably can see. Looking at this, you're like, oh, well, it looks like these are equally likely. There's no reason I would land on red more than green, for example. While over here, it is not equally likely. It looks much more likely that I'm going to land on green. So this is what is talking about, when we talk about this, we're talking about probability. How likely is it that something is going to happen? And when I say something, I'm talking about an event or an outcome. Those are kind of very rather interchangeable words that you could use to say what are the things that could happen. So with these two spinners, let's just start by listing the sample space. And I'm going to represent the sample space using a tree diagram that branches off to all of the different possible outcomes. So we could say, if I spin this, what are the things that I could land on in one spin? I could land on red, I could land on green, I could land on black. That's my sample space. That's the same for both of my spinners. However, what's different is the theoretical probability of landing on each of those colors in the two spinners. Theoretical probability is what I expect to happen based on the outcomes that I see and how those outcomes are related to each other. So I think I kind of messed up when I talked about it as forming a theory, because I think a lot of people thought that that just meant take a guess, it'll be fine. It needs to be an educated guess. So it is a mathematical explanation of how likely it would be to have one outcome occur versus another. So the theoretical probability, and I'll just use TP to shorthand that, the theoretical probability of landing on spinner A is the same for all of them. And since it's the same for all of them, I need to take my 100% certainty that something will happen and cut it up into the three pieces. So I could say R's probability is 1/3, G's probability is 1/3, and B's probability is 1/3. For both of those, that would be also approximately 33%, which is approximately 33 hundredths. And you can list a probability in all three forms. Now, when you should see that when you have your outcomes and you add them up, you're going to end up with 100% or one whole, because it's certain something is going to happen. We just don't know what it is that's going to happen. When they're equally likely outcomes, you're going to have the same fraction, the same percent, or the same decimal for each of your outcomes in the sample space. Now for spinner B, they should not look the same. Based off of what I see here, I know that green looks like it's the largest. In fact, if I kind of dissected it, it is taking up 2/4 of the area, or 1/2. So the theoretical probability of landing on green is going to be 1/2. The theoretical probability of landing on blue, it's only 1 out of 4, so it would be 1/4. And of landing on black would be 1/4 as well. So although my sample space is the same, the theoretical probability of my outcomes is not. And I could write those also as 0.25 or 25 hundredths, 50 hundredths, and 25 hundredths. And those all together are going to add up to 1, or 100% chance that something is going to happen. So this could let me make some decisions. Like if I were playing a game and I needed to choose a color that I was going to make my color. And I was playing for spinner A, it doesn't matter what color I want to make my color, because it really is equally likely that anything could happen. It's truly random. Over here on spinner B, though, if I were being strategic and I was like, pick a color, I would pick green. I have a better chance of winning if I choose green, and I know that based on the picture that I see, based on the probability that I have. There is a higher chance that I'm going to land on green. So I can use theoretical probability to inform decisions that I make. We saw that with Deal or No Deal, where you had to make a choice about whether you were going to continue or not based on what the odds were that you were going to get something that was better than the outcome that you were being offered, the deal that you were being offered. But we never know exactly what's going to happen. If we did, we would be psychic, and we would all have a lot more money than we do. So we have to take experimental probability into account as well. Experimental probability shows you what happens when you do it. And it's not significantly different from theoretical probability. It just takes into account the fact that you don't know exactly what's going to happen, and sometimes you just need to see what happens as you do trials over and over and over again. So the experimental probability is going to involve actually playing. For example, perhaps I spun this spinner 10 times, and in those 10 times I land on the green 2 times, the red 5 times, and the black 3 times. Out of my 10 trials, then, the experimental probability would be based on how often I saw the green happening. So my experimental probability would be 2 green out of the 10 total, or 1/5. My red would be 5 out of 10, or 1/2. And the black, would be 3 out of 10. Again, if I add those together, it needs to add up to 1 whole, because this accounts for all of the things that happen when I spun on those 10 turns. This doesn't look like it matches my theoretical probability. 10 spins. If you only have 1/3 of a chance of each of those things happening each time, then you, especially with a lower number of trials, don't know what's going to happen. It really takes collecting better and better data in order to say, does this match my theoretical probability? You're going to get better data the more trials you do, because as you do more trials, chance is going to start to even out, and you're going to see patterns that are going to match the theoretical probability. So if I did this 100 times, I would be more likely to see something like 30, 35, and 25. So I'm getting closer to 1/3, 1/3, and 1/3. If I did 1,000 trials and I saw something like 330, 320, 327, and 336, 330. This is where we see, can I count? 330 would be 660, 660, 960, 987. We see something that's getting closer to thirds. So you're going to start to see your theoretical probability matching your experimental probability as you do perform more trials. But when you're talking about experimental probability, you're always saying, how many times did the outcome occur out of how many times did you do the trial in all? It's related to theoretical probability, where you would have the number of times that the outcome is related to whatever your situation is out of the total number of outcomes. So in this case here, we had 2 out of the 4 were green, so the theoretical probability of a green would be 2/4. We're always thinking about something out of the total number of outcomes, just like when you're making any fraction. So things to remember. Theoretical probability, that is your most mathematical explanation of what's going on with probability. Experimental probability, that's when you see randomness in real life and what happens when you actually test these things out. And as you do more and more trials and collect more and more data, you should see that your theoretical probability and your experimental probability are going to match up. Next week we're going to talk about compound probability, which is when you have more than one thing happening. So like instead of rolling a die once, you do it twice. Or instead of flipping a coin once, you do it twice. And we're going to think about how that affects the probability of certain things happening. Have a great weekend, and I will see you on Monday.